Sometimes I catch myself wondering why we create objects for every class in our system and why we don't use statics instead. And what is it about statics that people seem to dislike? What's up, YouTube? Welcome to this next video on the series Let's Talk. Today we're going to be talking about a few things. I'm going to put them all together because I think they are related, but this video is in many ways a continuation of last week's video. So if you haven't watched last week's video, I'll put a link to it over here. You need to understand what I would use today, the terms behavior only classes and state only classes. So I'll be using that here. But just so you're clear, please go and watch that video before you watch this one if you haven't watched that yet. All right, so today's, by the way, this book, I don't know if you can see this. There you go. This book itself, I mean the physical book, not the print, if you will. This specific book is bought this in 1996. It's been with me since then. It looks brand new. It looks like I've not read the book or even bothered to open it. But this book has been extremely well read by me. I've read it many times. So if you don't have this book, it's not the best read. So I don't necessarily recommend this book, unfortunately, because it's not. It's written in, well, the code is in C++ or Smalltalk, and it's all very succinct. And, I think they're not trying to explain anything. They're just trying to show how well they know their stuff for the most part. And that's my take on it. Because if you can't explain something, you don't know it well enough. Anyway, there are some key things in this book that I'll be talking about today. But essentially, the talk is about instances, as in objects, inheritance, as in one of the tenets of O programming, and polymorphism, and how I use these three things, or don't use these three things in my system. To start with, I'm going to talk about these DTOs, or state-only objects, as I called them in the last video, but these are classes that maintain state. And you need instances of these because you generally have, let's say, collections of the same thing. And so you want to have every instance maintain its own data, right? A collection of customers, a collection of orders, and things of that nature. For those classes, I have instances, meaning objects, but I don't have inheritance. All right? Why not? Because listen, you learn from your failures. You don't learn from successes. You only learn from failures. At least that's how I see it. You might learn a few things from your successes, but it's more like you're patting yourself on the back. With failures, you have no option but to accept failure and start to learn from what things did and did not work. So that you kind of have this introspective idea about things when you have failed. And what I've learned from some of my past failures, now failures may be a stronger term, but of course, if you're being very hard on your designs, on your, let's say, the outcome of your systems that you've built, and you really nitpick and trying to find things, what you could do to improve your systems, then that's what I'm calling a failure. It's not like the system failed. It's just there are something that I would have said, man, I would have done this differently. Because you're seeing hints of certain issues or problems, mainly to do with maintainability, comprehension of the system for new team members, things of that nature. That's the driver for me when I talk about programming with intent. That whole series, I'll put the link to the playlist over here. If you don't know what I'm talking about, there's like at least 40, 50 videos on that playlist. Well, I don't know, something like a large number. And this video is driven from programming with intent. It's about the same idea. You are programming with intent, so show me your intent. So how do you write your code to show me? Maybe it could be my future self. It could be you joining the team in the future. Somebody else who's on the team but didn't do what I did, but you're kind of looking at the code after the fact. Whatever the me is. All right. So why don't I have inheritance in DTOs? Because I think that unnecessarily confuses the issue, and inheritance has issues. These are well documented. I won't repeat them here. These are well documented issues with inheritance. And I don't use inheritance unless I have the need for polymorphism. Let me back up a little bit. There are two kinds of inheritance. One is extension, or for the sake of extension. You're extending functionality from a parent class or an ancestor. So you get some behavior and some properties for free from the ancestor, and you want to extend or add more methods or properties to that ancestor. That's for extension, just for the sake of extension. The other kind of inheritance is purely for the sake of polymorphism. Why? Because polymorphism depends on it, which is the idea of being able to treat all classes in a family, the base class and all descendants, in a uniform fashion, which implies you're not extending. And that's what programming within two interfaces is all about. It's programmed to the interface, meaning that base classes interface. If you're new to this channel, when I say interface or interfaces, I don't mean blah, blah, blah. I just mean the public surface of a class or thing, interface, API. But in this case, interface. So polymorphism requires you to program to the interface, which is the base class's set of methods typically, and not implementation, meaning you don't have to worry about what additional functionality that might have been added on to the descendants. So in other words, when you inherit, you're simply inheriting so that you can treat all descendants in a uniform fashion. Your intention is not to extend. Now, there could be commonality, common functionality that is rolled up into the base class. Descendants are happy to use that implementation. I'm talking about extension, meaning adding on more than what the base class has. So if you were to type a variable of a certain base type, and then those methods or properties will go missing because you've extended, right? So two forms of inheritance, one for the sake of extension and one for the sake of polymorphism. I don't use inheritance for the sake of extension. I only use inheritance for the sake of polymorphism. Okay? But going back to the DTOs, the project I'm working on currently, one of the devs has convinced me. By convinced, I mean you got to make a really hard sell, twist my arm, make me see the light, and kind of prove beyond a reasonable doubt, if you will, to me that these classes, these DTOs, should have a common ancestor. And the reason I have given in to this in this particular project, and this is after many, many years of not doing it, is that there is a need for us to treat these same classes, these DTOs, in a uniform fashion in one part of our system. And as a result of which, that is the sort of the driver, that's the straw that broke the camel's back, the tipping point, if you will. Because we have this very strong need to treat these classes, these DTOs, in a uniform fashion, because they all share a certain set of properties. They all extend, but they all share a certain set of properties. And in this part of our system, we need to treat these classes in that uniform fashion. So yes, that's a very, very rare situation. I'm not talking about sharing the properties so that it saves you from having the trouble to declare the same properties. Okay? I'm talking about when you use these classes, you have a need to use or look at just those properties, the commonality. You don't care for the instance type, if you will, right? So you're treating those classes polymorphically. So don't make the mistake of saying because of these two classes or these 10 classes share the same properties that they are inheriting from each other, from the ancestor. It's because it's on the flip side. You have a need to treat them uniformly. Very different thing, right? So I'm not reusing or extending. Therefore, I'm not inheriting because of reuse or extension. I'm inheriting for the sake of treating them in a uniform fashion. Right? Okay. So the DTOs, I generally don't inherit. I simply redefine the same class. Even if the properties are the same, I don't really care. Right? It's not about some sort of a comfort of, oh my gosh, I got to repeat myself. It doesn't matter. They are completely different entities. They just belong different hierarchies. They don't share anything. All right. What about instances now? We all talk about objects, which means it's an instance, right? It's an instance of some class. In my systems, I don't really have a lot of objects. Now, when I do inherit and when I do create an instance, it's generally for the sake of polymorphism. I love polymorphism. So that's something I use classes for, definitely, because then I prefer polymorphism over, let's say, higher order functions, which is sort of the functional style of getting polymorphism, right? I call that poor man's polymorphism. If you haven't seen that video of mine on delegates and higher order functions, I'll put a link to it over here. I talk about this thing, how I call it poor man's polymorphism, because there's no ceremony, right? You simply define a delegate and you're done. There's no class hierarchy, ancestor, descendants, and the lack of ceremony is why I'm calling it a poor man's polymorphism. Its polymorphism is just very quick and easy, or dirty, quick and dirty. You get to polymorphism without a lot of ceremony. I prefer polymorphism. Okay, so at that point, I will inherit. I want to treat them uniformly. I'll create an instance, because of course, the only way to pull off polymorphism is to create an instance of some class and then treat these instances in a uniform fashion. If I don't have a class for which I have no need for polymorphic behaviors, and there's just one class and that's it, right? There's no family, there's no hierarchy. I don't create an instance. Why would you need to create an instance of class that, one, you either don't inherit from, or two, you don't have multiple, let's say, versions, implementations of it? These are not DTOs. These are behavior only classes now I'm talking about. Sorry, I should have probably made mention of that. This is behavior only classes. They don't have state. If the class doesn't have state or doesn't maintain state, and the class is it's not belonging to a family, if you will, right, where you're intending to use this polymorphically, then why do you need an instance? Simple question, right? Simple answer. You don't. I don't do that. So if I have a class, these are important classes. So don't get me wrong. These are not classes that you throw away from industry. They're not just like, baby classes. No. These are forming some real important critical functions in the system. They're highly specialized in what they do. And as a result, there's no deviation, as you don't have variations of the same theme. In the business system, there's no need for polymorphic behavior. And so, but that functionality is still, highly critical to the business. But it's a static class. That's just how it is. Because I don't have a need for an instance. Why would I create an object just for the heck of it? Like, what's the point of that? What am I getting? There's no multiple objects, multiple instances with different state. I don't have state in these classes. So there's no need for it to be a instance. And I don't intend to use these things polymorphically. So there's no inheritance. Therefore, no need to create an instance. Therefore, I don't create an instance. Now, before you get to using statics, I strongly suggest watching this other video of mine. I think I talk about statics. I forget the title, but there's something about statics. I'll put a link over here. It's paramount you understand statics. You need to understand statics in and out. Because you make one mistake with these statics and that's it. Your life is going to be miserable. Okay? It's very difficult to understand some of these problems, because if you don't understand what statics are, you won't recognize the problem and you won't pinpoint it to these static classes that you may have been either misusing or wrongly programmed. So be sure you understand what statics are, how they should be implemented. Watch that video. And only when you're comfortable and truly understand statics, that's when I suggest you use statics. So statics have their place. I'm just trying to get across that point. Static classes have their place. And in my system, the proportion of statics to non-static classes is 50-50, not more, right? So above 50. Because a lot of my classes are like that. They're all specialized classes, 1, 2, 3 methods. And they are used by other classes. So they have the functionality that they provide, and that functionality is required. And that's it. And there's no other version of this functionality. That's all I have in my need for my system. I also want to mention that I don't use inheritance, but I do and will use composition. And that's what some of this book actually mentions. They say favor composition over inheritance as well, besides the program to interface, not implementation. That's another one of the sort of the tenets, I think, of this book. If you have this book, don't get anything free the first 2 chapters. That's it. Everything you need to know is right there. So it's just the first chapter, I forget. I think it's just the first chapter, not the second. Okay, back to this inheritance thing. So composition, favor composition over inheritance. Why? Because first of all, you mitigate the issues that the well-known and documented issues with inheritance, that's kind of gone. Secondly, with inheritance, you have this thing about white box versus black box, meaning descendants can see ancestor things, right? Methods and properties. And it feels a bit dirty because that it seems to be breaking encapsulation in some ways. So with composition, because you're dealing with the class's public surface, so hopefully you understand composition. I'm not going to explain it. Basically, some people call it aggregation, some people call it composition. For this conversation, they're one and the same thing, but they're not actually the same. So if you understand aggregation, it's the same thing. Composition and aggregation are the same for the purpose of this discussion. So when you're compositing or aggregating one class, let's say class A, aggregates classes B and C, which means depends on B and C. These B and C, in my case, would probably be static, right? Because I have no need for, there's no polymorphic behavior required. So if there's no polymorphic behavior required, these classes can just be static. They're already behavior classes, which means they have no state, which means there's no need for an instance. They don't inherit. So again, there's no need for an instance. They don't have this, they don't inherit from a family, if you will, an ancestor. They're just static. So class A could depend on or aggregate or composite classes B and C. These classes B and C are static. Class A is giving me the full functionality of what I need. I don't need to know and don't want to know that class A depends on B or C. I don't want to know, right? I'm not interested. So why do people actually do that? Why do they create instances for classes where the criteria is met, which is they're, let's say, behavior only classes, they don't inherit and have no need for polymorphic behavior, but yet we go about creating instances of these classes? Well, I have a theory. It's the same, what's the word I'm looking for? It's the culprits are the same, right? Dependency injection, mocking, testing, especially testing and isolation. These are the same reason that people create classes all the time, because you can't test static classes. Okay, so let it be. Just test the outer class that aggregates these other classes. Right? Why do you have to test static classes? You don't have to test everything in isolation. Just pretend those classes don't exist. They're static. Just leave them alone. No. You got to create an instance for everything, because you have to be able to swap out everything for testing purposes. And you have just completely damaged your system with all this proliferation of testing needed things just rampant across your system and creating instances, right? Static classes have another advantage, that is, I'll take something out from that video on static stamp that I talked about there, so just so you can have this conversation, but please don't assume if you haven't watched that video, you will understand what I'm saying here. In that video, I talk about type objects and class objects. Every time you touch a class in the .NET framework or any class in the .NET world, you have to have a type object. If you're creating instances of these classes, meaning new something or the other, then you also have class objects. Class objects is what we would call objects, instances. The type object already exists. Only then can you create class objects. With statics, you only have type objects. You don't have any class objects. What I'm getting at is statics are less pressure on the garbage collector. Now, this may not be a big deal. I'm certainly not saying this is a reason to use statics, right? But you should know there's additional behavior or additional benefit there. Performance in terms of method calls are much faster, or microseconds faster, again, much faster. But it depends on what you're doing, right? At the end of the day, if you're calling the same method 1,000,000 times a second, I've had systems where I've called methods, the request from the outside was 10,000 requests per second, but some methods, because they were being called from within a loop, they were going easily, over 500,000 per second, right? So if you're working at that level, then the little bit of performance improvement the statics give you does matter, and the lack of additional garbage, therefore less pressure on the garbage collector, is a huge difference. It's a big difference. I'm not saying that's the reason to go to statics, but it's nice to know that there's an additional benefit to statics. So I think, as I said, most people stay away from statics because It's not conducive to testing and isolation and mocking and dependency injection. But to me, that's not a reason. The idea that I damage my design to support testing, I just can't fathom that. It's just too much of a compromise to make. That's not to say I don't test, right? I mean, maybe you don't know I test or not, but I do. I test my system. I test all of it. Not that I chase this code coverage thing, but I end up getting 98 to 100% code coverage just by doing my testing. I don't even bother looking at the code coverage until after the fact. And it's very simple to get that code coverage because I'm testing the functionality of the system. I'm not testing the parts and the pieces. I'm testing the functionality. I don't care what classes give me that functionality. And there may be classes where I test composite, what I call a composite class composite tests. These are the same kind of tests I was talking about, where class A might composite a B and a C, and a D maybe, and these are the other ones, the static classes. I don't care. For me, the outer class is the class that provides that functionality that's either critical or complex to the system, and I would decide to test that class, that composite, independently of my entire system. Right? So there's time when I do that, I'll do that as well, but it's a case-by-case basis. I don't say that's just how it's going to happen for every kind of class. If it's either complex or it's critical to the business, then as a team, we may decide to test that composite. We see it as one class. Internally, it might have other classes or use other classes. That's fine. When you composite, because you're dealing with the public surface of these classes that you're compositing, it's black box reuse, not white box, right? Because you can't see the internal. Even that outer class, the one that's aggregating the other classes, can only see the public surface of these classes. It composites. So it's a black box reuse rather than a white box reuse, right? And that's one of the problems with inheritance, the white box reuse, that is mitigated by composition. Okay, so I don't know what you guys think about this with regards to why create instances and why inherit, since inheritance certainly is one of the three tenets of object-oriented programming. And instances as well. It's instances, right? And what are you doing if you don't create instances? And I'm saying I don't want to create instances. Why would I want an instance? In programming with intent, you are showing me your intent. If you don't intend to maintain state, therefore you don't create instances, then don't create instances. Show me your intent. Be clear in the way you write the code and the way you design these systems. So I understand my future self, me coming into the team at a future date or at some point later, 5-10 years after the system is written. If I look at the code, I understand your intention. You don't intend for this class to inherit from something, so it is it's not inheriting, it's sealed. You don't intend to create descents from it. And if it's the stateless class, then why do you need an instance? Right? Make it static. If the class is static right off the get-go, then I know that that's your intention. All these things you were trying to tell me was just marking the one class as static, and that's it. You told me all this stuff, right? So it's this communication or conversation you could be having with your future self or other people on the team without saying much. Static says a lot, right? Sealed says a lot. By the way, just while I'm on this topic of inheritance, when you do inherit, keep your hierarchy shallow, meaning there's let's say a base class ancestor, and there's second level down, there's a bunch of descendants. So it's a wide hierarchy, but shallow, meaning it's just not going deep, right? The other problem with inheritance is that as you get deeper, things get a bit too complicated and hairy, and it's just a nightmare. So I strongly recommend, if you do use inheritance for whatever purposes, hopefully for polymorphism, that's the only time I use inheritance, is they're shallow. Base class, one level down. That's it for the most part. All right. I hope this was fun. I hope you guys enjoyed it. If you have, please give me a thumbs up, and I will see you next time.